Friends, we'll start the next technical session. Mr. Amar Patil is the chairperson for this session. Many of us would already know Mr. Amar Patil from Mahindra & Mahindra, but I would still introduce him formally. Mr. Amar Patil is the General Manager and Unit Head of the Foundry of the Auto Sector at Kandivali Plant, Mahindra & Mahindra, Mumbai. Currently managing vehicle, body, press and paint shop of Mahindra & Mahindra. Mr. Patil is a graduate in Mechanical Engineering, postgraduate in Foundry Technology and MBA in Finance. He's a certified lead practitioner and Six Sigma Black Belt qualifications. Has over 27 years experience in manufacturing. Has great exposure to TPM and Kaizen. Has earned several appreciation awards and Mr. Patil is actively involved in all the IF activities. I would request Shitish to please escort Mr. Patil to the dais.
Thanks, Mr. Sen, for a nice introduction. So now we'll begin with the last session of this, today's last session. I take this opportunity to introduce Mr. Rajesh Goel. About his profile, currently he is pursuing PhD in Sustainable Manufacturing. He is graduate in Mechanical Engineering, MS Postgraduate in Quality Management from BITS Pilani. Has over 23 years of experience, worked with various organizations like Rotopumps, Mitsui, DCM Engineering, Escorts, Sigma Electrical Manufacturing. He specialized in various quality management tools. It's one of the utmost important topics in today's scenario in foundry industry. Basically, why it is so? Because that foundry industry has been considered as is not that organized sector vis-a-vis that other matured sector like auto and other industries. Because I have gotten an experience of that auto as well as foundry also simultaneously. So even during yesterday's session also, one of the speaker is basically casting buyer. He has mentioned this Tata Cummins. This quality is a paramount because quality is very, very important in foundry industries whenever you are dealing with that customer like OEMs and all. Rajesh has presented many papers in national as well as international forums. He's a certified lead auditor for OSHA's 18001, ISO 9001, ISO 14001, TS 1649, a big list. He's a membership panel at various capacity, member of IIF, Indian Institute of Quality Management, member of National Safety Council of India, and Indian Society for Quality. Today's topic is cost of quality analysis, a window to economic sustainability. So I request Mr. Rajesh to take this forward.
Good afternoon. I know it's a tough time for me because I am between lunch and the present. It's a lot of people start feeling hungry around 12:30. So I would say like Honorable our session chair, Amar Patil, I know him very well since long. And the audience, ladies and gentlemen, it's a great honor for me to be here to share my thought. It's a little different topic because I was hearing day before yesterday's a presentation, a lot of authors, presenters has talked on the multiple technical aspect of the foundry. And when I look at overall picture and overall thoughts, a lot of things which I would say not in foundry people are using like an automotive industries. Because generally foundry people say, okay, whatever rejections happen, we'll just remelt it and go away. But is that is the case? No. The theme of our this IF or IFC conference 70 is beyond the boundaries. when we talk about beyond the boundaries, it's exponential growth of the companies across the countries. But one very, very important thing when we talk about beyond the boundaries is the competitiveness. Sustainability for the long term of the foundries into the manufacturing environment. I'm going to talk about a little bit on one aspect when we talk about sustainability. I would say there are three windows under the sustainability. One is the economic sustainability. Second is the environmental sustainability, where my previous colleague speaker were talking about the pollution. So that is a part of the economic sustainability. The third window of sustainability is the ethical, social sustainability, where we talk about the people, health, safety, growth of the people, the human capital. So I'm going to touch upon only one window of the overall sustainable development or sustainable manufacturing, which is the economic part of the sustainability called economic sustainability. And under that, there's a one very important aspect of economic sustainability when we talk about is the cost of quality, cost of poor quality. I'm going to touch upon that aspect and why it is very, very important in foundry, because I have spent around 15 years in different kind of foundry, ferrous, non-ferrous, aluminum, die casting. And again, the important part, as I mentioned earlier, foundry people always say, okay, rejection happened, just melt it and move away. But in 2012, when I start working on cost of quality, because it was a very important tool was in the automotive sector, manufacturing sector, but foundry people were kind of ignoring these aspects. When I start working on this tool, it was an eye-opener for our management when we look at how much expenses we are doing on cost of quality as a part of percentage of sale versus how much we are wasting on cost of poor quality as a percentage of sale, and we'll able to know what is the potential where we can improve our quality, we can reduce our cost of poor quality, and we increase our profitability. Very, very important statement. I know a lot of people knows about him, Dr. Deming, right? He's a quality guru. And he has given a very, very good statement. Managers and workers speak the language of the things, because they people talk about the production kitna hua, kitne kg melt kiya, how much is the LM has happened, what is the energy. But the senior leader in the company, they talk about only one language, and that's the language of money. So very good statement given by him, and look at it here, very, very critical. Earlier, like we were thinking about, okay, what is the cost is coming, we'll add our profit and then we'll sell it to market. But now the situation is not that. Now the price is fixed because we are competing across the globe, across the country between the competitions. The price is fixed. We know, okay, cast iron, maybe 120 rupees, 130, 140 rupees a kg. We know that market, the prices are fixed. Now, if you have to earn profit, if you have to increase our profitability, the only one part left out is reduce your cost. And that's where the cost of poor quality or cost of quality come into the picture. Good quality will always increase your profitability, it will reduce your cost. Vice versa, poor quality will increase your wastages, it will reduce your profitability. Nowadays, Six Sigma is a very buzzword in a lot of manufacturing industry, rather in service industries also. But a lot of people says we are working on Six Sigma. But when I go in little deep and asking the question, what is your cost of poor quality as a percentage of sales? Most of the time, we couldn't able to get the answer. So here is a table which has been prepared very simple. If people are saying we are working on Six Sigma, their cost of quality should be less than 10% of their sale. Less than 10% of the sale. Very high number. If people are working in 3 Sigma, 2 Sigma, the percentage of sale cost of poor quality will be 20 to 30%. So you can understand the opportunity, phenomenal opportunity for the saving for the organization. I will take a little bit time on just to make you understand about the cost of poor quality or cost of quality. When you talk about cost of quality, there are two components. One is the conformance cost, second is the non-conformance. Conformance is, yes, it is required because we have to do inspection, we have to do certain process like training, maintenance, preventive maintenance. This is required cost. This is to make process robust. But the second part, which is a non-conformance, is an undesirable cost. But it always happen in the organization. Only thing, how much we can reduce this cost, that will make us more profitable. When we talk about cost of quality, these are the four parameters of that: prevention cost, appraisal cost, internal failure costs, and external failure costs. I will just go a little step over and a little more detail on that. What are those and what are the different factors we have to capture this cost? If you look at the first two costs, is the cost of conformance. We have to do these activities so that our product became good and we can satisfy our customer. Like prevention cost. Prevention talks a lot of things. All your check sheet preparations, trainings, machine preventive maintenance will come a little bit. All these are the prevention costs. Appraisal costs are all your inspections or the appraisal cost. But it is required. But customer doesn't pay for that. The second part is the failure cost, which is internal failure and external failure. Internal failure could be rejection, rework, breakdown of the machines. External failure could be product recall. It could be customer end rejections. It could be loss of share in the market, customer dissatisfaction. So the second part of the window, the bottom part, is called cost of poor quality. So I will touch base more on the cost of poor quality and how we'll see if you focus more on the cost of conformance or cost of attaining quality, how you can reduce your cost of non-conformance. These are some example of prevention cost. And when we look at any organization, we are spending money. We are spending money on all these aspects like quality planning. We are giving training to people, but where that cost is going, it's a prevention cost. Why we are training we are making train our people so that they can avoid the defect in the process. We can make our customer more satisfied and our process can become robust. So that is the cost which we are spending on the prevention side of the processes. Process defining itself, customer survey. We do a lot of customer survey to understand what customer exactly want. Then pre-production reviews, technical manuals preparation so that customer use our product exactly the way it should be when it comes to the applications. Detailed product engineering, advanced product quality planning, APQP tools, FMEA, all these are nothing. These are the prevention expenses. And similarly, so on and so forth. Even housekeeping is a prevention tool. It's a prevention cost. And we spend money on housekeeping, but with a very low heart, because we see it's a wastage. But rather, it's nothing. It's making your process more robust when it comes to the housekeeping. So similarly, on appraisal side, I will come. All the inspection, all the tests which are mandatory to make your product certified for a good quality. So that is the appraisal cost. Product audit. The IATF requirement, ISO requirement. So product audit has to be done by company, by the organization, by the customer, by the third party. All these costs are the conformance costs. It is required. It's mandatory. Similarly, the system audit. You must be knowing 9,000, 14,000 IATF audit costs. Those are nothing. Those are appraisal costs so that you make sure your systems are working so that your processes are robust and you are making assurance that product which is coming out from these processes is a good product. Prototype development. A lot of other stuff is there. So all these are the appraisal costs which done on the process, on the product. Now we'll come to very important part, the failure cost, which is the cost of poor quality. Substandard product. There's a requirement from the customer, but our product doesn't meet it. Sometimes let us give on the discount prices. So it's a substandard product. Scrap or rework. That's a common no-brainer game. Everybody knows about it. Reinspection. We thought reinspection is not a cost. Sometimes I'd seen a lot of people talk about, we do 200% inspection, we do 300% inspection. So that bad product doesn't go to customer. But making 200% inspection is a cost to the company. It's a failure cost. Why? Because we are not able to produce the right product in the first goal. That is the reason we have to do a multiple time inspection on the product. It's a failure cost. Redesign or engineering change. Process modifications. Payroll error. It's a HR related. It's a cost to company. It's a failure. So any failure which happen in the gambit inside the boundary wall of an organization is an internal failure. So a lot of other things like equipment breakdown, accident, injuries, those are the failure costs within the organization. Even absenteeism, people doesn't come on time. Organization has to pay the cost of loss of production. And a lot of other sale, like loss of sale, delivery failure, that is also an internal failure cost. So all the cost, if you do look at it and put it in umbrella, all the costs associated with this factor, you can see how much cost as an organization we are paying and opportunity available to reduce it and increase our profitability. I will touch base on the external failure. Product recall, I mentioned nowadays we every day talk about, earlier it was in automotive sector, but now engineering sector, FMCG, medicines. So a lot of companies are facing this product recall issue. Customer complaint handling, customer service errors, product return, analysis. Sometimes warranty claims has come and then we do analysis. There is a separate team in the company whose job is only to do the warranty analysis. So whatever the cost occurring at to that level, it's an external failure cost. Late payment. Sometimes customer hold payment because there is a quality issue. Until and unless you clear the debit or give the credit to customer, they will not pay you. So all these are the costs associated with the external failure cost. And the bottom one, which is very important, customer dissatisfaction. We cannot count it or make it in terms of money, but over a period of time, you can see how it is converted into the loss of sale. Again, everybody knows about it. It's a kind of top portion of the iceberg. Generally, people talk about the top of the iceberg when we start about the cost of poor quality. And the bigger picture is below. We can see much more depth analysis of cost of poor quality if you want to do it. Important part is focus. We have to bring it on and expose the hidden factory inside the factory. That is the way the cost of poor quality analysis rectification start. Develop a ongoing measurement system, how you are going to capture this cost and later on come to the analysis. Once your analysis is done, how you are going to start the breakthrough improvement on cost of poor quality. So I am talking today presentation or topic only on the analysis part. Breakthrough improvement or action plan comes later because most of the time we really don't know where we are losing our money. If you do our analysis in depth, we get the right thing on the table, I'm sure 50% of the job is done because we know where we are losing our money. Very important pie. If you look at it, as I told, there are two parts, controllable and non-controllable costs. Look at it in the top, it's a controllable cost, prevention and appraisal. Bottom all are output. And generally I had seen talking people in the foundry or in any industry, we are controlling rejection. I have a question to the audience. Can you control rejection directly? No. You have to control only the input. Or if you are able to control your input, output will automatically come correct. But generally people say we are controlling rejection. And rejection is what? Input or output? Rejection is output. So don't focus on the rejection control. Focus on the input, the controllable parameter, the top one, prevention and appraisal cost. Rest is all output. And it happens in most of the organization because our focus is the resultant. We miss the bigger picture, which is a controllable cost. There is no attention to it and everybody will start cribbing or getting frustration. We are not improving because our focus is not on the improvement. Our focus is on controlling the output. So my submission to all, focus on the input cost. It will take time, but over a period of time, your output will start improving. This is the one of a case study of a company which is been done long back. Look at it. They were spending, like total revenue of the company was 100 million and the prevention cost was only 2%, which is 0.4% million. Appraisal was 20%, that's a 4 million. So altogether prevention and appraisal, they were spending 4.4 million. And the bottom part, which is cost of poor quality internal failure, was 45%, cost to $9 million. And external failure was 33%, cost to $6.6 million. And the cost of quality was $20 million. on $100 million, $20 million was cost of quality. And cost of poor quality was $15.6 million out of $20 million. Once they start this program, and you can see, still the cost, prevention cost, they increase to the 60%, which was $3.6 million, and appraisal 1.2, which is 4.8. You can see the last slide. Here it was $4.4 million. It was still there were $4.4 million. They had increased a little bit to $4.8 million. But the major change happened is where? $4 million was the appraisal cost, and prevention cost was only $0.4 million. The focus has been increased to prevention. They had increased from $0.2 million to $3.6 million. Appraisal cost they had reduced earlier because they were focused more on, okay, test karo, inspection karo, and send the product. So now their focus has been shifted to more on the prevention. So, and the advantage you can see in the bottom part. $4.8 million was the prevention and appraisal cost. The failure cost has reduced to $1.2 million, and total cost became $6 million from $20 million. You can imagine if a company of $100 million having $14 million extra in the pocket, they can do miracle in terms of capacity expansion, in terms of employee satisfaction, whatever they want to do. So this is the power of analysis of cost of quality or cost of poor quality. And you can see over a period of graph. It is not a, I would say, short-term process. No. If people think, okay, this is a magic wind, I'm sorry to say it will not turn around your company in day one. It will take 2 year, 3 year, 4 year, 5 year based on the system complexity and infrastructure of the company. But it short is a process which will help you to reduce your failure costs over a period of time. And you can see in the graph. The first one is like price of non-conformance, and the top one green one is the price of conformance and the total cost of quality. Over a period of time, you increase price for the conformance or cost of conformance, your cost of non-conformance is going to reduce. This is one of our foundry example where we work in 2012 onward. And now the questions come how to do this analysis, what are the baseline, how to start it. So don't go with a hi-fi system. Nowadays we can talk about a lot of digitalizations, SAP, ERP, but it is a simple basic Excel work. You can start it. At least you know first where you are before making a step toward the next level. So it's a kind of a very, very broader level. There were the companies having 4 plants. And the cost, conversion cost, basically, you can see the manufacturing variable cost of foundry, it's $1 per kg. Then the post-foundry, they were having machine shop, so consumable cost, post-foundry consumable cost, and raw material cost and metal loss. It's a very, very broader level analysis. Initial phase has been done just to capture the number. And you can see these are the parameter which has been taken for the analysis of that particular company. How to capture this cost, from where we can get this capture. So there were 9 parameters has been selected in the external cost, and internal cost there was only 1 parameter has been selected. It's a rejection cost, because there are multiple other parameters. If you take all 30-40 parameters together, I'm sure you are going to bog down with the very high level of data analysis, and people will start feeling, no, this is not useful. So start with the basic macro level, capture the major cost, and then go into the deep dive year by year so that you can improve the process. There's an Excel format. This is a simple Excel format, can be used. Nothing complicated. All the parameter has been put it here, like equipment maintenance cost, right? All this stuff, total prevention cost, you can see. You can see the total amount which is being expanded on that and percentage of the total. So all these parameters can be analyzed at the different node. What is the total cost of quality, like that company? Just an example I'm saying. So percentage you can calculate, very simple, basic Excel format. But important part is the data. If you don't have the right data, your assumptions will be wrong. So please first create a platform from where you will able to get this data, and the data should be right. Otherwise, your inference will be wrong. You will take wrong decision. You can do later on, you can play with the data as the way you want. You can play the graph, you can do the all kind of analysis, just example, right? look at the trend, whatever you want to do. And again, if you have multi-location, right, it's always help. This is the analysis which has been done, and you can prioritize your thing. Here you can see the plant Z is having contribution in total cost of quality was 43%. And you can see on a sale of $27 million, the cost of poor quality was $1 million, which is 7.8 crore almost. So you can imagine 7.8 crore. If you reduce only half of that, forget about elimination, reduce half of that, so you have 3.5 crore rupees in your pocket, direct profit increase. So that is the power of cost of quality analysis. As I said, the advantage, reducing the cost of poor quality is one of the best way to increase the company profitability. Provides manageable entity and a single overview of the quality. We do a lot of review in the company. We do rejection review, we do system audit review, we do management review, but ultimately everything goes to the cost of poor quality and cost of quality. If this is in line with the organization, all are the subset of it. All are the input to improve this cost. Align the company quality goals. Prioritize the problem, as I mentioned, plant-wise, system-wise, process-wise. You can do a lot of analysis. Correctly distributed, controllable, non-controllable cost, and promote the effective use of the resources into the company. Important. Data is a lot like garbage, right? So you need to know what you are going to do with it before you start collecting. I have seen millions of paper are being filled day in, day out in the company. And first week of April, we call a kabadiwala and just sold them off. Nobody looks on those paper. So whenever you are collecting information, please make sure you are going to use this information. Otherwise, it will be just collecting the garbage. Thank you very much. I'm happy for any question you want.
Any questions? We can take 2 questions. Yeah, looking at the time constraint. Yeah, please. Please use mic.
You said that we need to control the input costs or the inputs. We will control. But what is then the role of process control?
Process control are also part of input, because in process control we have multiple parameters. I'm just talking about foundry. We have pouring temperature, we have melting temperature, we have chemical composition. All these are the input to process. If you control all these process parameter, I'm sure your output will be good way, whichever is being on. Did I answer your question?
Yeah. Sure.
Okay.
We can control input, we can control input, we can control output, but sometimes environment also affects our casting due to the variation in temperature.
Environmental is also a input to your process. It's an external environment, but it's an input to the process. Because I know in foundry, controlling an environment is not that way, but you have to adopt certain processes. Like I'm just giving an example. I've seen a few of the iron foundry have a 3 different range of the pouring temperature. Okay, summer they have a different range of pouring temperature. Rainy season they have a different range of pouring temperature. Winter they have a different range of pouring temperature. It is nothing, they are not controlling the environment, but they are changing their input with respect to environmental factor so that their output will become better.
Thank you, sir.
Just to add into this, that input, there might be some interpretation. Input is not only raw material, because input is nothing but a resources, 4M, what we call man, machine, material, method, and what you mentioned, environment. So all put together, input and proactive approach can lead to your good casting is output. That is what is the total crux of this presentation. So excellent presentation.
Thank you, sir.
Ramesh. Nice. It's really is a thought provoking for the foundry industry, because quality only we look at that reactive approach. If you have a proactive approach, means what he has mentioned is definitely we can do a wonder. And I can just give one example of means what you mentioned, that dollar, and also simple example, if you have a foundry of 20,000 metric ton per annum capacity and having 1% rejection is a 200 ton casting is a rejection. If you have a material cost 60-65% is a 60-65 rupees, you can get some kind of amount of a recovery, and rest of this is a conversion cost, all your resources and all kind of a thing. So which can cost you around 1 crore 30 lakhs rupees per percent of the rejection. So you need to work on those rejection parameters with all this approach, means what he has taught us. It's very, very, very beautifully he has articulated that entire presentation. So you can take this input and use and introspect your processes and start doing it. It can give wonder to your foundry. Thanks a lot. Thanks. Very nice presentation. Yeah, please.
Yeah, it's working. We are following this COPQ tooling, and it really helps us to improve our bottom line. The two things we came across after this technology implemented on plant, the major contribution to the reduction is only 2 points. Like one is manual intervention, and the second one is not adherence to the process. So these are leading to maximum our 60% of rejection cost, like COPQ. So this industry 4.0, IoT, artificial, will it going to help us to further reduce this manual intervention and this adherence to process to increase further our bottom line? Like
Industry 4.0 definitely will help you to reduce the manual intervention, because it can display, it can give you a lot of control. Automation definitely. But here my first thing is, at least you should know, do the analysis where you are losing. And like lot of company I had seen, they just scratch. वो बोलते हैं ना हिंदी में, वो धूल साफ किया surface का. The deeper you will go, the exposure will be high. So yes, first look at the surface, then go in one step down. Maybe you had just started, look at it in more detail, you will see more opportunity for that. Thank you. Thank you, everyone.
Any more question? Okay. So on behalf of IF, I would like to hand over a token of appreciation, memento, to Mr. Rajesh Goel. But I'm sure you are going to make it more attractive and more informative and more kind of a takeaway everyone can take along with them. So let me introduce Mr. Sapan Kumar Biswas. He's a technical manager, Elchem South Asia Private Limited. He's a graduate in metallurgy from Jadavpur University, Kolkata. Advanced program for marketing professional, APMP from IMC. Previously worked with IVP Limited, Perfect Engineering Limited. Currently in Elchem since 1999, almost 23 years of experience with Elchem. Presently working as a technical manager, Southeast Asia. Member of Elchem Global Technical Customer Service Team. As a solution provider and technical support. So now I request Sopan to start his presentation.
Wonderful introduction. Good afternoon to Foundyman. So I know this is very difficult time before this lunch break, but I'll try to make it more interesting. So this is mainly for my earlier colleagues. They have presented and shown this different cost advantage part on the different topics. But in my presentation is the multiple stage of alloy additions on the shrinkage control, mainly for the ductile iron. Mainly for this ductile iron component, my presentation, I'll try to demonstrate in different conditions. In this presentation, there is a 4 different case study on different conditions, mainly how this foundry man can minimize the rejection at the last stage. This is mainly for micro shrinkage related. So in present scenario, this OEM is asking for, there is the more complicated castings and they are looking for this weight reductions, and there is also the section thickness reduction more challenging, and also there is their requirement is very stringent requirement. Another is raw material situation is now very much fluctuating. So considering this, all these factors, so it's difficult to achieve this quality casting in case of very thin and critical castings. It is all of this automotive component. In this case, is bracket is one of the most critical and safety component. There will be hub related component and differential case housings. So first case study is by using this different type of nodularizer, mainly this lanthanum bearing nodularizer, it how much effect on the shrinkage control. In case of second case study is the 2 stage of inoculation, not the same composition. It will be the different composition, but in 2 different stages. One is the ladle inoculation, another will be the in mold stream inoculation. In third case study, this effect of the preconditioner. Actually, when we are using this raw material, but without any thermal analysis, difficult to measure the metal quality. But by checking this chill, also you can check this metal quality. But in thermal analysis, you will get, before the pouring the casting, you will get the metal quality conditions. So in this case, also on case studies with the application of preconditioner, that is helping to control on the metallurgical rejection. In fourth case study, there is a special conditioner in place of steel punching in the covering material. So in that case, there will be no ladle inoculation. Directly you can pour the casting, only this in-mold inoculation will be sufficient. In case of shrinkage, there is the 3 major factor. One is the physical factor, another is the chemical, and third is the process. In chemical, physical factor is the mold condition, then another is the metal to sand ratio. Nowadays, most of the foundry, they are trying to reduce the sand, so then they are facing lot of problem. And another is the getting system. Then there is, because of this complication, this is the radius of this casting also creating problem. Chemical factor mainly is the carbon equivalent, and especially is the carbon content. Another is the low ultra sulfur content in base metal. Some foundry they are using so high purity raw material, and sometimes they are facing very low final sulfur level. But in case of ductile iron, you need certain minimum level of sulfur, at least 0.005%. And sometimes because of this raw material changes, there's a lot of trace element that is also creating lot of metallurgical defect. Then process related, mainly is the nucleation level. When you metal hold for long times in furnace, definitely there will be a deterioration on the nucleation level. So, but every time you cannot change the alloy addition content. Suppose metal is hold, but still you have to pour the castings. So definitely that times you will face the metallurgical rejection. If you use this high performing preconditioner, definitely it will help to hold the oxygen level in the melt, and you will get the consistent result. By thermal analysis, before pouring castings, you will get idea. This will give clear idea, is there any chances for metallurgical shrinkage. From this, normally in thermal analysis, this green portion, that is graphite G3, is called as the graphite factor 3. So in that stage, if it is that percentage is high, normally in case of very good castings, when there is almost shrinkage is microporosity is 0, then in our experience we got more than 80-85% G3. So that means that indicates the your nodulite and nodule count will be high. So in this case study, mainly for using this lanthanum bearing ferrosilicon magnesium, it is helping to control the microporosity. In case of shrinkage factor, then residual magnesium also you have to consider, because when the residual magnesium on the higher side, that is also increase the shrinkage tendency. Normally foundry people, they think if it is written magnesium on the higher side, there will be no compacted graphite. This is correct. But another problem, then definitely there will be chances of shrinkage tendency is more. Another disadvantage, because this written magnesium is a very strong carbide stabilizer. When your written magnesium level will be high, the definite chances of getting this carbide. And high written magnesium also creating this low nodule count. So that factor we have to consider when you are making this safety critical component of ductile iron. In lanthanum based ferrosilicon magnesium is developed in 1982. So after this 20 years, so that was the in-mold process. When later on, maybe after 20 years, Elchem developed this lanthanum bearing ferrosilicon magnesium in the ladle process, not in the in-mold. In-mold also, very few foundries is using in-mold. But in this case, in this, you can see this left picture. This on left side is the normal ferrosilicon magnesium. It is contained this cerium. And other right side, that picture is casting is produced with lanthanum bearing ferrosilicon magnesium. By only just changing the rare earth, cerium also rare earth and lanthanum also rare earth, but only by changing this cerium to lanthanum, there is a drastic improvement on the micro shrinkage control. So this is the, and with lanthanum bearing magnesium, definitely if you compare this cerium containing magnesium and lanthanum, in lanthanum you will get the highest nodule count and nodulity. Along with this, if it is change this inoculation package also, definitely it will help to control the microporosity. This is another case study, is mainly for bracket, and this is very safety critical component. In this foundry, when we are interacting with their technical team, they have mentioned that in this component, in the thin section area, there is two problems. Either in the chilled issue or this carbide issue, and another is the shrinkage microporosity in the thin section area. This foundry using the lanthanum bearing ferrosilicon magnesium, but inoculant, they are using calcium barium ferrosilicon magnesium. Then on basis of our technical interaction, then we suggested try to change the inoculation package. Calcium barium inoculant is moderate inoculant efficiency. If you compare with cerium containing inoculant, is lower than cerium containing. In case of cerium, this is the high performing inoculant, and consumption will be also less, but you will get the better nodule count and nodulity. So in this case, what we have done, earlier they are using both the barium containing inoculant in the ladle and mold stream also. But we have changes, is the cerium containing, on inoculant is the cerium, another is the zircon containing. But both the inoculant, it is coated with sulfur or oxygen. Because in ductile iron, you need certain oxygen and sulfur at the last stage. During this magnesium treatment, if you can add high purity recarburizer along with this magnesium treatment also, drastically you will get the better nodule count and nodulity. So this inoculant, both the inoculant is developed, is coated with the sulfur and oxygen. Because in the last stage is introducing the sulfur or oxygen in the melt, that is helping to increase the nodule count and nodulity. So you can see this left side, that picture is with carbide, and that melt was produced with calcium barium inoculant, but magnesium both cases is the same, lanthanum, but inoculant was the different. In right side, it is cerium containing and zircon containing inoculant, two-stage inoculant. Both inoculant is the coated in sulfur or oxygen. So you can see this drastic, that I have mentioned this green portion, that G3. When your nodule count and nodulity will improve, definite in thermal analysis you will get the highest G3. So always target to how we can improve the G3 factor. So by improving the nucleation potential and using this high performing ferrosilicon magnesium and inoculant both, definite you can eliminate this microporosity without adding any chill. Most of the foundry, when there is the microporosity, another issue, try to use the chill. But in this case, there is no chill addition. Only by changing this inoculation magnesium package, customer is able to produce castings without any carbide issue, without any shrinkage issue. This is third case study. This casting is export castings. And after this final machining, they always observe this pin, like as a pinhole type, but that is not the pinhole. So in this case, after final machining, if it is, you can observe that any shrinkage or any defect is very expensive rejection. Before that, at shop floor rejection, that is cost will be less, but after this final machining is really, I think 3 or 4 times cost. So in this foundry, they are also using our this lanthanum bearing ferrosilicon magnesium and inoculant or the calcium barium. So we have also done this thermal analysis. Normally when we are visiting any foundries, we try to check the metal quality by thermal analysis. It will give the metal health conditions. So you can see as a ECG of human body. So we try to check this metal quality through thermal analysis. It will give the idea. And always we try to take these defective castings. We have a laboratory, and in that area we always do the detailed analysis. We have ACM facility also. So that gives the clear idea what is the main problem and what corrective action is necessary for them. So in this case, we suggested just go for this preconditioner. So in precondition, actually it is the high aluminum and zircon containing. Main purpose to add the precondition in the melting furnace along with the charge mix. Maybe after 20% addition of steel scrap, you need to add this preconditioner. It is contained this high aluminum and zircon. Main purpose, this zircon is aluminum, when in the adding into the melting furnace, it is reacting with oxygen and creating this zirconium oxide and aluminum oxide. That oxide is the holding the nucleation level. So you need certain oxygen in the melt. You cannot directly add to oxygen in the melt, but you need certain media which can hold the oxygen in the melt. So that's why the zircon and aluminum containing product, it is helping to hold the oxygen in the melt by creating the zirconium oxide and aluminum oxide. So if you check this thermal analysis without adding this preconditioner and another is with preconditioner, definitely it will give the difference picture. In these two cases, the left side is without preconditioner and right side with preconditioner. Drastic difference in the same component but microstructure. Both cases, you can see this nodal count, nodulite is acceptable by customer. But main problem is there is the microporosity. In case of left side without any preconditioning, so there is the shrinkage porosity is observed after final machining. So by changing this, it is giving this consistency of the nucleation potential. And third case is the mainly in this case, most of the in magnesium treatment is the ferrosilicon magnesium, then top of this steel punching. That is the standard practice for sandwich process. For in this case, what we have done, maintain this other parameter almost similar, but changes the steel punching cover. In place of steel punching, we have this specially designed is covering material. It contains barium, mainly is barium calcium with some other ingredient. So purpose was that, say normally in case of sandwich process, maybe 1% magnesium and 1.2% is steel cover. So in this case, we have replaced the steel cover and that covering material was around 0.5, 0.6%. So there will be no ladle inoculation. Directly then pour the castings If it is very thin and critical castings, maybe it will be regarded as last stage as the mold inoculation, steam inoculation. Otherwise, in medium section casting, there is no need for any ladle inoculation. It will help by changing this from steel punching to this conditioner. It will help to reduce the tapping temperature, at least 15 to 20 degrees temperature. So, by reducing this 15 to 20 degree temperature, there is both two side effect. One is, if you increase the melting temperature or tapping temperature, definitely it will deteriorate the quality of this metal. But reducing this 15-20 degree, it will help to minimize the deterioration of the metal quality. And another is the power saving. So both cases there will be the saving, and final is you will get the better structure. In this case, these two cases, one is the steel covering. Both cases microstructure, if you see, both are acceptable. But drastic difference in the nodule count with this conditioner. When your nodule count will increase, definitely your machinability will improve. So that will also impact on your machining cost. So you have to calculate in both sides. Maybe one side, maybe alloy cost will be high, but another you are getting this better machinability. Your tool consumption will be less. So altogether, definitely you will get the cost effective. So in all these four cases, a different condition, main purpose how this foundry man can eliminate this micro shrinkage, that is the main purpose to present this case study. Is all our case study in the various customer within India. It is not outside case study, and regularly we are interact in various foundries to help them how they can minimize or eliminate this micro shrinkage. Not only micro shrinkage, our main purpose is to help the foundry man to minimize the metallurgical rejection. Mainly our product range is the alloy, treatment alloy and inoculant. So this is, with this and our expertise, we have 30 technical experts all over the world. When we are facing any difficulties, we are interacting each other, and we are trying to get information from other countries also, because all the countries in foundry man producing similar component, maybe different process. But by using this, definite any foundries, they can improve their production cost. Mainly this is the treatment alloy cost.
Thank you, Mr. Sapan. Now this floor is open for question and answer. We'll take two questions. So anyone has a question, please? Yeah. Please pass on mic to Mr. Pankaj.
Hello. Sir, I have two questions. First of all, I would like to know, in gray iron, we maintain sulfur in between 0.06 to 0.08 in order to enhance nucleation potential. So first, I would like to know how sulfur helps in enhancing nucleation potential. And my second question is, in AG iron, due to presence of magnesium, we tend to decrease sulfur content below 0.05, as you mentioned. Then how in AG iron we manage to maintain same level of nucleation potential without sulfur content? So both are contradicting. In gray iron, we need to maintain it so that we can enhance nucleation. And in both, in gray and in AG, we do inoculation. Then
So
how, yeah.
in case of gray iron, is mainly this nucleus, you call this manganese sulfide. So in that case, in gray iron, you have to maintain the sulfur and manganese ratio, otherwise you will not get the sufficient nucleus, this manganese sulfide. But in case of AG iron, after this magnesium reaction, there will be the magnesium oxide, magnesium sulfide, and there is some complex oxide also. So both cases in nucleus is the different. In gray iron is the manganese sulfide is the main, but in case of ductile iron is the magnesium related, magnesium oxide, magnesium sulfide, and calcium magnesium complex. So both cases the nucleus is different. But you need in case of ductile iron also, you need this sulfur, but in the lower range. But because of this high number of magnesium oxide and sulfide, it is helping to generate this, increasing the nucleus. So after adding this inoculant, it is helping to graphite precipitation. But in gray iron, is manganese sulfide is the main with some other nucleus. So that's why this both cases will be different. But in gray iron, suppose if you using any strontium based inoculant, so in that case, you have to maintain at least minimum is 0.07 level of sulfur. Otherwise, strontium element, it will not react as same as calcium barium, because affinity towards sulfur with the strontium is very poor as compared to barium calcium. So that's why in barium calcium inoculant, maybe you can operate 0.05, 0.06, but in strontium, you have to maintain minimum 0.7. Otherwise, you will not get the full effect of inoculation for gray iron.
Thank you.
Yeah, please pass on mic to.
Eliminated.
Yes.
So you have taken trials at an XYZ foundry.
Yes.
And you mentioned in your talk that the cost is dependent on the foundry. What was your conclusion by eliminating the CRC cover and increasing the new additions? Was it a cost beneficial or same cost or expensive?
Now, whatever when we are giving any solution, if it is found that is the expensive, definitely they will not apply. So either similar or it should be lesser. But maybe cost may be similar, but is there other advantage? That part also, maybe on a step. In this case, suppose after magnesium treatment, maybe you take 1 ton treatment, then you are splitting in 2 different ladle. So then you are adding inoculant in ladle. So there will be some time, and again you have to clean the slag. So if you go with this combination, so there will be no need for this ladle inoculation. So your time you will be saving, and slag related, whatever this slag related, definitely there will be some defect on the slag inclusion. In barium is helping to clean up the slag, because it is helping to convert the slag into this like a popcorn. So it will be more easier to clean the slag when you go with this combination. But in case of the suppose steel punching, definitely there will be some oil and rusty combination and inconsistency. Whatever we are buying, definitely lot to lot there will be some variation. Always there will be some chances of trace element level. So that part we will also eliminate. Maybe cost may be the similar, but other advantage that maybe immediately you can not convert into the monetary. But overall, definitely it will be helpful. Whatever we have supplying to different foundries, always they are ready to immediately they start this calculation. Without benefit, nobody will go for that. So that is sure.
Yeah. Thank you, Mr. Biswas, for a wonderful presentation. Though a lot of technical stuff, you made it very easy, simple. To tell us how we can produce the HG ion more effectively and efficiently at low cost. So thank you very much for your session. With this, on behalf of IIF, I would like to hand over a memento. As a token of appreciation, I call upon Mr. Sebal Sen to do this honor.
Hello. Good afternoon, everyone. I would like to call upon our Sanjay Desai, who had taken the session chairmanship on day before yesterday. You have given the memento? I thought you have been given. Achha, I call upon to you to give the memento to our session found in charge. The session chairman, Mr. Amar Patil, and also we have to give a memento to the in charge of this session, all the sessions. Thank you, Mr. Sanjay Desai. Thank you, Saibal Singh ji and Amar Patil ji. Thank you so much.